This conference will now be recorded.
Okay, so we already talked about the software development lifecycle and different stages and phases of software development life cycles, Sandeep. So, uh, you want me to repeat one more time, or you okay if we continue with the Agile methodologies?
Yeah, we can continue with the other one.
Yeah. So, I are you familiar with Agile methodologies by any chance earlier, or this
Uh,
is the first time you are hearing?
no, no.
Okay. So, yeah, anyways, I usually ask this question because if you know it, it will be a recap for you. If you don't know, that's okay. It will be from the beginning. Okay. So, in our last conversation, in our last meeting, we talked about agile methodologies, and we actually talked about in agile methodology, we have iterations, small intervals. In those smaller intervals, could be a 1 week, 2 weeks iteration we have, and in these 2 weeks of iteration, we can complete with the requirement gathering, designing, development, testing, and review with the customer. And once customer is in line with the implementation, or the implementation that we have done is in line with customer requirement, then we are moving the product to the production environment. So this entire SDLC phases, we are completing in 2 week iteration or a week iteration, and this is entirely called a sprint in Agile world. So a sprint is a 1 week cycle or 2 week cycle. There is no hard and fast rule that every company has to go with 1 week cycle or 2 week cycle or 3 week cycle or 4 week cycle. But usually most of the organizations are going with a 2 week cycle, 2 weeks iteration of, for the sprint. Okay. So, and we talked about the advantages of Agile model. Obviously, the biggest advantage we are getting with Agile comparing to waterfall is customer satisfaction. So all the time we actually want to get the satisfaction of the customer, and frequently we are getting the satisfaction from the customer on the requirements we are completing. And once we get the sign off from the customer, we can actually focus on other functionalities. And then other thing is requirements are very dynamic in Agile methodologies. When I say requirements are dynamic, let's say Amazon, for example, they are coming up with festive offers. They are coming up with the Independence Day offers, like July 4th in US or August 15 in India during the Freedom uh, s- uh, this 1st August to 15th August. They actually go with a freedom sale. Even in other countries, depends on the special days, occasions, they come up with some offers. So application should be flexible enough to cater those dynamic changes. And second example is, let's say in when you are in US, we have Best Buy, we have Target, Walmart, and other stores. So if Best Buy is coming up with an offer, Best Buy says that I give 40% off or 20% off to the customer. Other companies, Walmart, Target, they actually come up with a price match, and they want to they actually look at providing more benefits to the customer so that customers can get attracted by these companies, these electronic stores or these main stores. So they are changing their business. They are dynamically changing their requirements. They are dynamically changing their nature of business, and that is going to happen in no, I mean, very short intervals, as they need to go with tactical plans to increase their business. They change their business model, and they come up with new requirements very often. In that particular scenario, Agile is the best fit for the organization, for the companies. Okay, and take one more example, like uh, we have these satellite systems, or we have the healthcare systems, health scanning, ECG, and other systems. For these systems, we want 100% accuracy, right? When we talk about satellite systems or rocket launchers or mission criticals applications or systems, we definitely want to be sure we are getting the requirements with 100% accuracy. So we need to have series of discussions, these business users having series of discussions with the customers for n number of times to ensure that they are getting the accurate information from the customers. Once they get the accurate information, very less chances, very rare chances of changing the requirements, right? So if you are looking at a satellite system, very rare chances, once they get a sign of about the satellite system, there won't be there won't be changes unless it is extremely needed. So for those use cases, we go with waterfall model, Sandeep. Okay, so for any dynamic business requirements, we go with Agile, and for the requirements where we need 100% accuracy towards the requirement, then we go with waterfall. Okay, so that's the reason we say Agile methodology, though it has its own advantages, there are few disadvantages. Like when we have the complex projects, most of the cases in complex projects, we look at waterfall rather Agile. And second one is, in waterfall, I did mention like for every phase of the SDLC, we ensure we are creating the artifacts, we are creating the documents. Like when you talk about the requirements, for requirements, we create requirement specification document or system specification document, or you can call it functional specification document. Okay, once we create these documents, we get the sign off from the customer on the requirement side. For getting that requirements and getting the sign off might take couple of weeks to couple of months, but we are ensuring that we have those artifacts in place. Okay, and then we go with the designing, we create the technical design document and getting the sign off from the customer, then go with the implementation. So we have every requirement captured in the document, and in even in the case of someone is leaving the organization, leaving the project, if even if a key individual, key developer leaving the project or company, we still have the document well defined, well maintained in a common location. So whoever is replacing that individual who is leaving the organization or already left the organization, for that individual, this document can work as a knowledge share, because we are getting the requirements, we are maintaining those requirements in a solid state in waterfall. But in Agile, we don't maintain the document unless there is a definite need. So we don't maintain the document for each and every functionality in Agile. So if someone is leaving middle of the sprint, then there is a difficulty of others scaling up and continue starting the implementation from day one, or that individual might take couple of days to couple of weeks to months as well to understand the requirements. So that is a second disadvantages we have with Agile. And obviously success of the project depends on customer satisfaction, customer interaction. If customer is too rigid, too harsh, then every sprint when we are showing something, if customer come back and say, oh no, this is not I want, you are showing me X version but I want Y version. If they keep on coming up with new requirements or change of requirements in every sprint, we can't complete the project. So these are few disadvantages we have with Agile model when we have certain conditions, right? Certain scenarios when we go through. Okay, so that is basically on Agile methodology or Agile model. And then we have Lean model, which is similar to Agile model, but only the difference is when you look at the Agile model, after every sprint, we are waiting for customer satisfaction, or we are waiting for customer feedback. Instead of satisfaction, we can say it's a feedback. So this is the waste of time that every team member is more towards moving. So uh, between every sprint, there is a day or two uh, we are wasting or not productive, right? So to eliminate this waste, companies are looking at lean model, and in lean model, when they are releasing certain functionalities in one sprint without waiting for customer review of those functionalities, development can start the second sprint. Okay, if customer come back and provide a constructive feedback or suggested any changes, they will go with hip sprint. That's a separate sprint they run, but they don't waste the time of 1 or 2 days for getting the review from the customer in lean model comparing to agile model. So that is a major difference we have between agile and lean model. So nowadays most of the organizations, they don't want to have any wastage of time of individuals, so they are going with a mixed version of waterfall, agile, lean, and they are coming up with their own custom model, I would say. Okay, so they want requirements to be signed off, but they want those requirements sign off has to happen in shorter intervals, not taking months together for creating the requirements and getting the sign off from the customer. And every sprint of 2 weeks, they want a runnable code implemented, tested, and released to the customer. And after every sprint, they don't want to wait for a day or two to get the customer review. Rather, they want to kickstart the next sprint. So this is basically the advantage we have with lean model. And as I said, these days customers are not strictly going with one or the other model. Sometimes they go with a hybrid model. That is a combination of one or all of these models. Okay, so that's mainly about the waterfall, agile, and lean models. So whenever companies want shorter development life cycles, then they go with either agile or lean model comparing to waterfall model. Okay, then When companies are getting benefit, companies able to complete the functionalities within a span of 2 weeks or within a span of 3 weeks or a week, depends on the sprint cycle. They are able to release the functionalities as per the customer needs within shorter intervals. So why companies are started looking at a DevOps process, a DevOps model? Though Agile is solving most of their problems of not waiting for the customer feedback for months together or years together. Okay, when Agile is solving, why companies are still looking for a advancement? I would say a advanced feature, which is Agile plus new enhancements or new features. So that is where we mainly talk about the DevOps process. Before I go to why DevOps, I want to hear from you if there are any questions, Sandeep.
No, I'm good with it.
Okay, so now let's say companies are using Agile methodology or waterfall methodology, but in most of the cases, we usually hear from the development team saying, okay, everything is working in my laptop or in my environment. And when the same functionality is moving to the test environment, testers are started complaining that the functionalities are not working as for the expectation. So there is a clear conflict between the developers and operations team, because developers they don't move any functionality to the testing unless the functionality is very well tested by the developers in their environment. But suddenly the same functionality is behaving weird or stopped working when it moves to the test environment. Then testers provide the feedback to the developer saying that, oh, this functionality is not working in the test environment, go and check why it is not working in these environments. Then developers can they usually say that, oh, look at my uh, environment, everything is looking fine. Even if developer is reviewing and making sure that the functionalities are working in their environment, testers can't go ahead and certify that, because they need to validate, they need to confirm the functionalities in the test environment, not in the dev environment. Okay, this happens when the manual interaction between the development and operations team happens. Let's say the developer is having the application running on XYZ software, and in XYZ software, you heard about Java, Sandeep? You should be right. Did you?
Yeah, yeah. Being a recruiter, I know
You
about
know the
the.
technologies, right? Perfect. Now, in Java, there are major and minor versions. Okay, we have Java 8, Java 11, Java 14, Java 17. Let's talk about Java 11. So, in dev environment, developers are running their application on Java 11. Okay, but the minor version of Java 11 is 2.3.4, for example. Okay, and when operations team are creating the test environment or the stage environment, so they got an instruction from the development team to install Java 11. Okay, so operations team installed Java 11 version, but the major version is fine, but the minor version is 2.3.7. Okay, so the version in developer mission is 2.3.4, but the version in test environment is 2.3.7. Because of that minor version, if there are any additional features implemented as part of the upgrades, as part of the patches, there's no guarantee that the functionality that is working in dev environment should be working in the same way when it moved to the test environment. Okay, so developer actually come back raise the concern to testers saying that, okay man, I installed Java 11 and in your case also you have Java 11, then why is this difference? Okay, and testers actually say, okay, I'm not worried too much about that. I can't see the functionalities working in the way they need to be. So you need to go and review why these functionalities are not working. And after a couple of days, they realize that, okay, there is an issue because of a minor version of the software installed in the test environment, and that is not meeting or that is not in line with the minor version installed in the dev environment. And this has happened because there is a manual communication happen by the development to the operations team to install Java 11 version, but they didn't mention about the minor version that they want to be installed in the test environment. Because of that operations team, there is a possibility that they have installed 11 of 2.3.7 instead of 2.3.4. Then automatically if there is a change in the minor version or in some cases major version as well, we see the conflicts, we see the differences of software, the application behavior, and application starts breaking in the test environment when it moves to the test. Okay, so to avoid this, we are looking at using the automation tools rather than having a manual communication between the developers and testers. We look at a automated process to run the same application that is very well working in dev environment uh, to be running in the same way in the test environment, stage environment, and finally to the production environment. And that is possible with a automation process by using automation tools. So the application that is running in dev environment seamlessly is working in test stage and prod, because the software version that we are using in dev, the same software version or the application is going to be running in test without manually interacting with operations team. And the same goes into stage without manual interaction with the operations team. So we actually make use of the automation tools like Docker. With Docker, we just create an image, and that image we are simply shipping it to the test stage and finally to the production environment. So that is going to help us to use the same major and minor version across environments. Like if I say my dev environment is Java 11 2.3.4, when I create image, I'm directly creating an image of same Java 11 2.3.4 version, and the same image going to be pushed into the test. Once it is validated by the test engineers, it will be moved to the stage environment. Once validated by the business analysts, it will be moved into the production environment. So same application, that is bundled with the operating system with the software is going to be run as is in test, stage, and production environment. So that is possible with DevOps, and again that is what we are making it possible by using the automation tools. So it's a collaboration between the development operations team by using the automation tools. So that is a typical definition we have for DevOps. Okay. So same I have explained, it is like when developer actually implementing the code, once it moves to the test environment, automatically testers can come back and say, oh man, the functionality is not working in line with our expectation. And obviously there is a conflict between the developer and test engineers because of the minor version that I already mentioned. And to avoid that, we are looking at DevOps tools to have the automated collaboration between the developers and operations team. So when we use DevOps, obviously there is no very less chances or no chances of version conflict, as we are moving the same application with the same operating system and the same softwares from dev to the test to the stage and finally to the production environment. So more productive, as we don't need to do a rework, and there is no no back and forth of the application, no back and forth on the software, and developers whatever the functionality they are implementing, there is no way that not going to work in the test environment or stage environment. So that's the reason we call it more productive. And here we have specialized teams here. So we have DevOps engineers who takes care of creating an automatic environment, all the required environments for developers to come up with their functionality implementation. And then we do frequent intervals, frequent releases of the application by using the DevOps, by using the automated DevOps tools. Okay, and that's mainly about the DevOps, the need of DevOps, Sandeep. And the definition, as I said, like it's a collaboration between the developers and operations team by using the automation tools. So these automation tools we use in the entire DevOps lifecycle or entire CI/CD pipeline. So when I talk about CI/CD pipeline, one is code maintenance, and then building the code and creating the Docker image for the code, and then moving the code into the common repository that is called the artifactory or artifact management, and finally deploying that code into the on-prem servers, cloud, or containers, Kubernetes containers. Okay. So in DevOps lifecycle, basically when we split it, we have three parts here. Left part is more towards the continuous development, continuous testing, and on the right side we have the continuous deployment and continuous monitoring. And there is a tool sitting in the middle of these processes, and that is called continuous integration tool or continuous integration. So when we talk about the continuous development, basically we start with gathering the requirements, planning the requirements. So there we use different tools, like we have Jira, Rally, which is from CA, now it is from Broadcom. And in Azure, we are using Azure boards. Okay, by using Azure boards or by using Jira boards or Rally boards, we ensure that we are getting the requirements from the customer, and then we are doing a functional breakdown of those requirements uh, to to split the bigger chunk into the smaller pieces and making sure we are completing those smaller pieces. And in Scrum world, we call them epic, theme, feature, user story, task. So task is the last one in feature development. Okay, in user story, sometimes if there are any defects identified by the test engineers, we can have a bug fix. Okay, so we can have the hard fix or bug fix. So overall, in our Azure boards, we create the project. Inside the project, we create the product backlog. That is entirely the backlog that we create for the product. Like if you talk about e-commerce application, in e-commerce application, we can have the product backlog that takes care of creating the user profile, maintaining the user profile. That is one module. And second one is the product list view. Like when you want to see all the products based on the category, then we can have that list. We create the backlog for the product list view, product detailed view, and then we have for shopping cart module and purchase order, payment gateway, alert notifications, and tracking the product. And finally, if there are any returns to be done, uh, going with the returning policies and returning the product. So all these are the different modules we have in e-commerce application, and for every part, for every module or for every service, we are creating separate feature under the Epic. Epic is the complete e-commerce application is the Epic in the product backlog, and from Epic, we actually create the features, or in some cases, we create the themes as well. So in features, as I said, like we have the user profile is one feature, and then we have the product list view is the second feature, product detail view is the third feature, and we have the shopping cart as the fourth feature. So in each feature, we can actually create multiple user stories. Like in product list detail view, take that an example. So in product detail view, I want to implement star rating. I want to get ratings from the customer. That is one user story. And second one is I want to provide the sizes of the products, small, medium, and large. That is second user story. And third user story is the different brands. That's the third one. Different categories is the fourth one. Different sizes, different, all these are the user stories that we are creating, and we are maintaining them in the backlog of the products and also the user stories. So under each user story, take an example of like a product detailed view. Okay, in the product detailed view, sizing, providing the different sizes of the product. That is the user story. Inside that different sizes, we want to show these different sizes options on the UI. That is called UI implementation. And when user is selecting small, medium, large, there is a backend implementation has to happen, and that backend implementation should be fetching the data from the database table. So here we create three different tasks. One is for the UI, second is for the service implementation, and third one is for the database tables. So this entirely the Azure boards implementation, and part of the sprint when we are implementing the tasks, user stories, and features. For those tasks, we progress like every day depends on how much we complete. We provide updates, we provide status in the in that rally board or in that Azure board. So we'll be talking in detail, Sandeep, on how we do that. Okay. And how we can create a project, how we can create a backlog, the product sprint, user story, yeah, product backlog and sprint backlog, and how we create features, user stories, and tasks. Inside that we will talk more in detail. Okay. And let's say you already have the features, user stories, and then uh, you can go with the coding implementation. So in coding implementation, we have uh, different integrated development environments. You did mention like you already taking care of the requirement, and you when we talk about the coders or coding, we use different editors, VS Code, or IntelliJ, or Eclipse. All these are the editors we use to write the code in Java or in .NET or in Python, Sandeep. So that is the coding that we do. Okay. So once we do the coding, there is a uh, source code repository that we need to maintain to store all our code into the common location. And there we talk about the Azure repos. Okay, Azure repos is a centralized location where we are maintaining project related code. So we'll be talking in detail when we are using the Azure repos, using the build, the code repositories, what exactly the benefits we are going to get. But that is mainly for Azure repo, and that is part of the code implementation. And then we have the build process. For different technologies, we have different build processes in place. Like for Java, we use Maven for the build, and for .NET we use MS Build for building the project, and also for Python we have Python build process. So once you have the build, you ensure that you are creating a machine understandable format of your code from user understandable format like English, plain English, to a machine understandable bytecode. That's zeros and ones. That is the build process we do. Okay. And then we do a unit testing of the application, and part of the unit testing, developers ensure that the functionalities are in line when they have implemented the functionalities. So this is entirely the build and the testing, and that is part of continuous testing process. Now when developers confirm everything is looking good in their local environment, they are moving those that code into the remote repository. And once they move the code into the remote repository, we enable a continuous integration process. So this continuous integration process is mainly takes care of automatically building the projects without manual intervention. Okay. And in continuous integration, we have different tools. We have Bamboo, Hudson, TeamCity, Circle CI, Travis CI, and in AWS we have Code Build in AWS and Code Pipeline, Azure Pipeline in Azure World. So we use Azure Pipeline to automatically build the project, and once we build the project, we can actually create a image of that particular project, and that image is a Docker image. And for that Docker image, we can actually maintain or we can push the Docker image into the ACR, Azure Container Registry, or we can have some registry, and Artifactory is what we call to maintain all our images. Now, once we have the Docker image, we can directly deploy the Docker image into the containers, into the server, into the cloud using the continuous deployment process. And for every release, we have the version of the application that we are moving to the common environment, to moving to the container deployment or to the cloud. So when you want to move your application into the cloud or to Kubernetes, first thing is you need to have your container ready. If it is Azure, it's a Azure container to be ready. If it is AWS, AWS EC2 container to be ready. Okay. To create a new EC2 container or to create an Azure container, we use infrastructure as code, IAC we call it, and that is Terraform. So using Terraform, we can directly create the containers, provision the container, provision the infrastructure. So once you have the infrastructure ready, you can directly do the deployment of your application in that particular environment. There we use a deployment configuration, and uh, and then if it is Kubernetes, we install and configure Kubernetes in terms of creating the namespaces and deployment services, network policies, and many other configurations we do in Kubernetes. And once you deploy the application into the Kubernetes, we are going with the continuous monitoring process. So there we are using different tools, Azure Monitor for Azure applications, and we have Grafana, Kibana, Prometheus, Splunk, and CloudWatch. All these are the tools we have. So how DevOps basically works? The same flow that I explained you. DevOps go through that process in every sprint. Every sprint we have the CI/CD pipeline, that is continuous integration, continuous development, and continuous deployment pipelines. We create these CI/CD pipelines in our project, and then we go through the continuous development where we actually pushing all our code into the version control system, that's Azure repo, and then we have the continuous integration with Azure pipeline and continuous deployment to move the application or to deploy the application into the different containers. And then once we confirm everything is good, moving from one environment to another environment. In case if there are any issues with the application, giving the feedback to the developer. So that is continuous monitoring and continuous feedback to the development team. So we talked about like continuous development. We have various tools. We go deeper on those tools, and continuous integration, that is Azure pipeline, and continuous deployment. We use different containerization platforms, virtualization platforms, or the Azure cloud environments. And continuous testing, we use different testing tools like for unit testing in Java world, we have JUnit. In .NET world, we have NUnit test cases, that is for unit testing. And then we have functional testing, that is with Selenium. Selenium mainly used for functional testing, and we have both the Java and .NET flavors. Okay. And then I said about continuous monitoring. We ensure that we are getting the feedback about the infrastructure, about the application using continuous monitoring tools. So these are the tools. Most of the times we hear we have the Jenkins, which is similar to Azure Pipeline, and we have Negios, similar to the Azure Monitor, that is for continuous monitoring, and we have the Docker Hub, Docker, Dockad, and this is Kubernetes, and we have Git, and we have Puppet and Ansible. So this Puppet and Ansible are automated configuration management tools. So I will be explaining you. Uh, I will be taking one session on why we need Puppet or Ansible, Sandeep. Okay. So all this is about the tools we are using for continuous testing, Selenium, continuous monitoring, Negios. So these tools, we have multiple, we have different tools. It depends on every project requirement. They choose one or the other tool. But as we are mainly focusing on Azure DevOps, so we will be using all Azure DevOps tools for CI/CD pipeline in our case. But I will be explaining you other tools as needed, Sandeep. Okay, you clear on that? Any
Yeah.
questions?
No, no, no. I got it.
Okay. So after every session, we have a quiz to to hear from you on your understanding, how much you understood, and no negative marking, no weight is given if you are answering the it not the correct one. Okay, so try answering the questions. So first one is, which of these software development methodologies are not suitable for large and complex projects? So we
I
have
believe
waterfall.
it's
Good.
waterfall, right? I believe it's waterfall and agile.
Okay, waterfall as well. These are two different. These are uh, two sides. So which is not suitable for large and complex projects in this case?
Waterfall.
Today I explained that. So
Okay, yeah,
if you
yeah. It's agile methodology.
yes, so if you have complex functionalities where you need 100% accuracy, like mission critical functionalities, mission critical applications, then agile methodology is not the best fit. We have to go with waterfall. Okay.
Yeah.
Yeah. So DevOps methodology was focused on solving the problem between the customers and software company.
True.
Which of these principles are not included in agile methodologies? So in agile methodology, we talked about 1 week sprint, 2 week sprint, right? So that is
Yeah.
frequent release cycles. We have that,
Yeah.
right? And second one, focus on customer feedback.
I believe
So
it's eliminating waste. C would be the right one.
okay, perfect. Which life cycle stage in DevOps helps in transition from one stage to another stage?
Continuous integration.
Perfect. Which tools among following helps in containerization?
Uh, Kubernetes.
Okay, we didn't go deeper on this one. Usually we see Jenkins as a continuous integration tool. Git is version control system. Kubernetes is an orchestration engine.
Okay.
Okay, it's an orchestration engine. And Docker is a containerization tool.
Okay. Okay. Got it.
Okay, so here the answer is Docker.
Docker.
Perfect. So with this, we completed the basic understanding of uh, the waterfall and Agile, the foundation, Sandeep. And tomorrow we will go one level down on understanding the Agile methodology and how we create product backlog, sprint backlog, and
Okay.
then what are the different ceremonies we have in Agile Scrum. Like we have sprint planning meeting, and then we have Scrum calls, how Scrum Master actually takes care of the Scrum calls, and what we talk in the Scrum. Okay, and then we have the sprint review meeting, what we cover part of the sprint review meeting, and then retrospection meeting. That's the other one. So we talk about, and then for every functionality, we have to provide estimates, right? In terms of how much time it is going to take, how many days the functionality is going to take. So that is the effort estimation. So how we provide effort estimation in the agile world. Okay, that we will be talking tomorrow, Sandeep.
Yeah,
And
sure.
then we actually go with agile boards, and we start with creating Azure boards by picking one project. Okay, we
Okay.
create a project and we talk about how to go with Azure boards in that project.
Oh, sure.
Okay. Okay, perfect. So you can get the recording, Sandeep. Yeah, they will be sharing the recording with you.
Oh, sure.
Okay. So this is the foundation. So I am not sharing you the hands-on as there is no hands-on for the foundation, but for Azure repos, Azure pipeline, there is a hands-on, couple of hands-on documents. You will be, I will be sharing those hands-on documents with you.
Yeah, sure.
Okay. So yeah, we will close this call n- unless you have any questions, Sandeep.
No, as you can see that with the class
Okay.
today.
Sure, then we will connect at the same time tomorrow, Sandeep.
Yeah, sure. Yeah.
Okay. Yeah. Bye.